binomials could do that, or we know that we can find probabilities out by finding this value, right? Going from data to z and then z here, right? There is our probability of something happening. How likely something has happened to find our percentile or the probability there. So because we know that we can prove that these distributions are normal, we then can go ahead and use normal CDF. So that's going to be our goal. We're going to prove that these things are normal. Then we're going to go ahead and set up a normal CDF problem just like we know. So the mean of our sampling distribution, we know if it's unbiased, is always equal to p. So my mean in this distribution, 0.80. My standard deviation in this distribution, we can go ahead and use our standard deviation formula, 0.80 times 1 minus 0.80 all over n. All right, so we have our mean and standard deviation. Go ahead and plug that into your calculator, and we go ahead and get a standard deviation of 0.0357. Oh, so ours means this, and our standard deviation is 0.0358 if we round up. Great. Well, if we have a mean and a standard deviation, we can make ourselves a nice little normal curve. But before I can do that, I need to check my three conditions. So n times p greater than 10, n times 1 minus p has to be greater than 10, and my whole population has to be bigger than 10 times the sample size. I'm going to actually go ahead and check all three of those conditions. So 125 times 0.80, is that bigger than 10? Check. 125 times 1 minus 0.8, bigger than 10? Check. So the population is a large school district. So a large school, we can assume that there's lots of kids. Is bigger than 10 times 125? Yes, we can assume a large school district is that big. So we have to check those conditions before we're able to start drawing our normal distribution. We then can go ahead and start drawing our normal distribution with our mean and standard deviation. I'm just going to kind of sloppily draw. This is not really all that accurate, but we got something like this. Okay. The question's asking, what's the probability that you're 7 percentage points away? So 7 percentage points away from 0.80 would be about 0.87, and 7 percentage points away would be about 0.73. So we know it's going to be this area. Well, if we want to find that area, let's go ahead and find our two z-scores. So our 0.73, our data point minus our mean, over our standard deviation. And our second z-score, our data point minus our mean over our standard deviation. We end up with two z-scores here. Let's go ahead and calculate those. Okay, so we have negative 1.955, so 96. And our upper one will be 1.96. It's the same thing, but just positive. Great. All right, we do normal CDF. Because we've proven that this is a normal distribution with a mean and a standard deviation given. Z left, Z right. Boom, 95% exactly, look at that, 0.95. So what is the probability? There is a 95% chance or probability that a simple random sample of size 125 will result within 7 percentage points of the true value. So, another